Hi students, good morning. Welcome to this video session. My name is Samuel Dominic Chukwuemeka, aka Sam Dom for Peace. You know, we need peace in this world, right? In this video session, we shall discuss the periodic table. This is the first video in a series of videos in the playlist on the periodic table. So we're going to be doing several videos on this topic so that you can really understand the periodic table. The notes, the calculators, and the other resources for this topic, the periodic table, is found on this website, www.periodic-tables.appspot.com. So if you want, this website will have both the notes, the links to the videos, the calculators, and the other resources. We are going to, the periodic table, as you know it, contains the elements. And then we've discussed about atom elements in the video on matter. On that video we talked about atoms, elements, compounds, molecules. So please, before you continue with this video, it is recommended that you view that video on matter. Very recommended, highly recommended that you view the video on matter so that you can have an idea of the terminologies we shall be using in this video. So in this first part, we are going to, because this is periodic table part 1, we shall discuss, we shall just list the first 20 elements of the periodic table. It is very important that at least you know the first 20 elements and their atomic numbers. It's very important. As we have discussed earlier, the atomic number of an element is the number of protons in the atom of the element. The number of protons in the atom of an element is also equal to the number of electrons in the atom of the element. So because the number of protons is equal to the number of electrons, the atom of an element is neutral. You know, the positively charged protons will balance out the negatively charged electrons. So we say that the charge on an atom is a neutral charge. There is no charge on an atom. It is neutral. An atom is electrically neutral because the number of protons in the atom of an element is equal to the number of electrons in the atom of the element. So, but we define atomic number as the number of protons in an atom of an element. So, but you know, some textbooks will still say it is also equal to the number of electrons, because the number of protons in an atom of an element is also equal to the number of electrons in the atom of an element. So the atomic numbers we are going to list here, just know, okay, that this has the number of protons and still has the number of electrons. We are going to use a mnemonic. I'm going to use a mnemonic. Then we can write the actual names. We will write the mnemonic. Mnemonic is something that you use to remember something. So we will list the mnemonic and you can recite it. Once you recite it, then you can easily list it. So we'll write the mnemonic, then we write the actual elements, and then we are going to look at how they are arranged in the periodic table. So we'll write I'm going to write the mnemonic, and then we'll write the actual element, and we'll write the atomic number. I'm going to use double line here. We write the mnemonic, then we write the actual element. Actually, write element and symbol. Let's write both element and the symbol. We write the element, we write the symbol, and then we write the atomic number. So we have element, we write symbol, and then here we write atomic number. So I'm going to make this one line. Okay, then I make this a double line to continue. Then we have mnemonic, the element, the symbol, and the atomic number. So let's get it, let's list it, and then we can now arrange it. We will explain how it's arranged in the periodic table. Symbol. We will explain how it's arranged in the periodic table. So we say hydrogen and helium likes hydrogen and helium likes berries borrowed from carbon. Hydrogen and helium likes berries borrowed from carbon as nitrogen and oxygen flourishes in neon. Okay, the first 10, I just listed the first 10. Okay, hydrogen and helium likes berries borrowed from carbon, as nitrogen and oxygen flourishes in neon. Now, how is that? You've already done a lot of work. So hydrogen and helium likes berries borrowed from carbon, as nitrogen and oxygen flourishes in neon. This is hydrogen, of course, and the symbol is H. This is helium. With this mnemonic, you see that you've done a lot of work already with this mnemonic. Helium is He, light is lithium, and that is Li. Berries is beryllium, and that is Be. Borrowed is boron, and that is B. Carbon is carbon, and that is C, uppercase. You see, for the element, for the symbols that is just one letter, they are uppercase. But if it has two letters, the first is uppercase and the second is lowercase. Like helium, H is uppercase, E is lowercase. Lithium, L is uppercase, I is lowercase. Please don't write lithium as lowercase Li. That is very wrong. It is L uppercase, I lowercase. So, and the atomic number of these is 1, 2, 3, 4, 5, 6. Okay, then here, nitrogen is still nitrogen. Symbol is N. Oxygen is still oxygen. Symbol is O. Flourishes is fluorine. Fluorine is F. And then neon is neon. And that is Ne. Neon. Of course, N is nitrogen. Ne is neon. So the first 10 elements, hydrogen and helium, likes berries borrowed from carbon, as nitrogen and oxygen flourishes in neon. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, but with the mnemonic, you can easily pick it up with the mnemonic. And with the mnemonic, it's almost half the, like you've listed a lot of the elements. Okay, so I'm just gonna come here and write it here: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, now let's do the next 10 elements. Okay. This video we're gonna do the first 20. So you can try to write it down on your own. Try to write it down on your own and see whether you can, whether you got it. Because you need, I repeat, you need to know how to list at a minimum, the first 20 elements, at a minimum. As a chemistry student, you should know, at a minimum, the first 20 elements offhand. You should. All right. Let's now write the next 10. So we have solid magnesium, and aluminum, are, you see, the ones that are not following, I put them on the side. Okay? Solid magnesium and aluminum are silly phosphorus. Solid magnesium and aluminum are silly phosphorus. As or you can say while sulfur and chlorine are used with potassium, and calcium. Okay? Solid magnesium and aluminum are solid phosphorus, while sulfur and chlorine argues with potassium and calcium. You've almost done you've almost done the whole thing. Solid is sodium. Sodium is Na. Natrium is a Latin name, natrium. That's where you get sodium from. Because some of these symbols are derived from Latin names. So you have natrium, and that is Na, natrium, which is your sodium. That's why we have Na. Okay, and this is 11, atomic number 11. Then we have magnesium here, magnesium, which is your Mg, that is 12. And you have your aluminum. You see that this mnemonic clears up a lot of, clears up most of them. Aluminum is Al, atomic number 13. Is silicon. Silicon is Si, atomic number 14. Then phosphorus is still phosphorus. Phosphorus, P, atomic number 15. Phosphorus. While sulfur is still sulfur. Sulfur is S, atomic number 16. Then chlorine is still chlorine. As you can see, this Cl, atomic number 17. Argues is argon. 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 Argon is a noble gas. Okay? Atomic number 18. And then we have potassium. Potassium is K. Symbol is uppercase K. So if it is one letter, it is uppercase. With two letters, first letter is uppercase, second letter is lowercase. And potassium is 19. Then calcium. Calcium, Ca, is 20. Okay, so we have solid, magnesium, and aluminum are silane, phosphorus, while sulfur and chlorine are used with potassium and calcium. So if they ask you how many electrons does an atom of aluminum have? 13. Because it has, like I said, atomic number is the number of protons. So an atom of aluminum has 13 protons. And then because the number of electrons in an atom is equal to the number of, because the number of protons in an atom is equal to the number of electrons in the atom. Also, you can say that an atom of aluminum has 13 electrons. So an atom of aluminum has 13 protons and 13 electrons. Okay? An atom of silicon has 14 protons and 14 electrons. An atom of magnesium has 12 protons and 12 electrons. So just, later we're going to go to the transition elements, which is the next 30, from 21 to 30. But this is the first 20 elements. Okay, hydrogen and helium likes berries borrowed from carbon. As nitrogen and oxygen flourishes the neon. Solid magnesium and aluminum are silane phosphorus, while sulfur and chlorine argues with potassium and calcium. Just like that. I didn't have to look up anything and I already know it. Okay? Now, we are going to now, before we end this video, we are going to see how this is arranged in the periodic table. Let's go ahead and see how they are arranged in the periodic table. So, what we're going to do here, we'll say, we'll put the first one here, hydrogen. Remember, it has atomic number 1. Okay? Here you have element Ma. And that is your Az anyway, your Az. Mass number, atomic number. So this guy is 1, atomic number 1. And don't worry about this. We're going in another video. I will explain it. Okay? Another video I will explain it. Mass number. I call it Ma. Mass number, atomic number. Okay, but we call it Az technically. But don't worry about it. Just know that this subscript is atomic number. That's the subscript. So I'm going to put 1 there. Okay? Then I'm going to come here, over here, I'll put helium. Helium is a noble gas. And don't worry, later we'll see why we'll put it there. Okay? Then I'm going to put lithium, which is 3. So I put 1, 2, 3. Beryllium is 4. And then I'm going to leave some space. I leave some space. Okay, I'm going to leave some space. I'll leave space here. I'll leave some space here. Then I'll write boron 5, carbon 6, atomic number 6, nitrogen. Let me shift helium. Let me move it more here. Helium, atomic number 2. So boron, carbon, nitrogen. Let me space this out. Nitrogen, oxygen, fluorine, neon. So 7, 8, 9, 10. Now, I just want you to know we have helium, we have neon. 2, 10. Okay, just know that, like I said, don't worry, we will see the reason why, because that's why we are learning periodic table. I will tell you the reason why they arrange it that way. Okay, so remember I have some space here. Okay, I have some space here. So then 10, 11, sodium is 11, magnesium is 12, and then I still have that space. Okay, I have aluminum 13, silicon 14, phosphorus 15, sulfur 16, chlorine is 17, argon 18. Okay, 2, 10, 18. These are noble gases. We will discuss that. Okay, but just know that 2 is further here, and then after helium is neon. You can just memorize it like H-E-N-E, helium, neon. But just know it's 2, 10, 18. As if you're adding 8. Here. Okay, but I don't want you, just know it for now with that. Then we now have potassium is 19, and then calcium is 20. So here we have this space, and then we have this space here. Let me use a yellow marker. Actually, let me also use the yellow marker here. So we have yellow chalk. So you have this space here. I'm going to denote it with a yellow chalk. And then you have 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So technically you have the next thing we'll discuss. We'll look at here, what is here? Okay, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That is here. We'll look at this. Transition elements. So that's the reason we put it there. Okay? But for now, just know that this is the way we arrange the first 20 elements in the periodic table. And then, another thing I would like you to know is that hydrogen, you see hydrogen that is here? You see how Y is here? And I will let you know later why we keep it here. But in something I want to say now about metals, from here, I'm going to circle this. The whole of here, these are metals. This guy, aluminum. Aluminum is also a metal. Okay, metal. And then boron, silicon. These two guys here. Okay, we're gonna call them metalloids. Metalloids or semi-metals. Some textbooks will say semi-metals. Semi-metals. And then these guys here. These guys you see here. Carbon, nitrogen, oxygen, fluorine, neon, hydrogen, helium, silicon, phosphorus, sulfur, chlorine, argon are non-metals. Non-metals. So as you can see, it's easily, as you can kind of see, the periodic table is done in such a way that you have easily demarcated the metals from the non-metals. And you know, if we fill up this, you can see more metals when we fill up this. Yeah, but it's just for you to just know that it's one of the reasons we can easily, these folks here are non-metals. Okay? And then these last folks here, helium, neon, argon, we'll discuss them later on. They are noble gases. So what I just want you to know today is the first 20 elements and how to arrange it like this. Okay? Metals, semi-metals, non-metals, we will still talk about them in subsequent videos. We will. Okay? But just what I want you to know is one of the reasons why it's arranged that way. You can easily demarcate the metals from the non-metals easily with the periodic table. So we're going to stop here for today and watch out for part 2. Okay? Thank you so much for listening, and you have a great